Okay, so this is going to be chapter 8.8, vectors. Here, these vectors are going to be very important because you're going to see them a lot in physics. You're also going to see them a lot in Calc 3. Let me just explain a little bit of what vectors are. So first, let's just start talking about the definition of a vector. So a vector basically is just a mathematical object. Okay, that has something called magnitude and direction. Okay, so that's basically what a vector is. So it's just some object that has magnitude and direction. So what I mean about magnitude, I'm talking about the size of the vector or the length of the vector. So I'm just going to write length. It can be how long this vector is, the size, so how much of this vector is going in that direction. And then it also has direction. So basically, not only does it have length and size, but it tells you in what direction this guy is going to. So you can kind of denote this as an angle. So usually it's given to you as an angle. It tells you the direction. Sometimes it can give you some sort of coordinate system, kind of how we did with bearing, where it was like northwest, southeast. Oops, that's not how you spell north. Northwest, east, south, whatever. So those are basically two different characteristics that describe a vector. Now, not only do you have vectors, but you also have something called scalars. And basically what scalars are is just a number describing a quantity. Okay, so you can kind of think about, scalars as just magnitude. So they don't tell you anything about the direction. So it's just basically a number. Okay, so that's basically what a scalar is. Now, let me give you an example of vectors. Some examples of vectors are the following. So you'll see this a lot in physics. So forces. So if we talk about 1 Newton, 3 Newtons, that's a measurement of force. That's what we call a vector. We also know in what direction the force is going to. Velocity. Velocity is a vector. Displacement is also a vector. Spin, which you'll know in Calc 3 exactly what a spin is. So what we usually call it curl. That's also what we call a vector. So those are examples of some vectors. So these vectors have to have length and direction. So if they don't give you that, then they're not vectors. So then we also have something called scalars. Okay, so scalars are just quantities, are just a number. So for example, speed. The speed of something just tells you, oh, this is basically how fast this is going, but it doesn't give you any direction. It just tells you the magnitude itself. Same thing with distance. Okay, so these are just scalar, just single numbers. They don't tell you anything about the direction. Now, whenever we talk about vectors, so here's some notation. We usually denote them with a letter, like U or V, and then we usually draw an arrow on the top. Sometimes you can see U with like the two, a full arrow, but one single arrow is fine. The reason why we do that is that we want to be able to differentiate between vectors and scalars. So scalars would just be, usually for scalars, we just write like C or K or A, but without the little arrow on the top. But for vectors, this is kind of how we do it. Basically, if you want to think about what a vector really is or how it's formed, it's basically this. So it's just an arrow pointing in a particular direction. So this arrow, notice that it has two different things. It has magnitude. So it goes from one point to another point. So this is what we call the tail of the vector, and this is what we call the head of the vector. So this is how you form a vector, or what a vector looks like in 2D space or whatever. And you actually can have three-dimensional vectors or multi-dimensional vectors. So I guess the question here is, how do you make a vector? So how do you make a vector? So let's say you had two different points. Usually what you're going to say is the initial point is going to be something like x1 comma y1. So some point P is x1 comma y1. Then you'll have something called the terminal point, and that's going to be maybe Q, and that's going to be x2 comma y2. So in order to form a vector V, the way that we do it is that we write it kind of in what we call component form. So we kind of write two little pointy brackets. We take the terminal x point, which is x2, and subtract the terminal and the initial point x1. And then the second one, we're going to do the same thing with the y. So y2 minus y1. So that's how you make a vector. You just subtract the points together. Okay? Now here, order does matter. Okay? Because if you were to do it the opposite way, you're going to get a negative vector. So basically, if you wanted to form a vector that was going from here to here, and instead you subtracted the wrong thing, then now the vector is going to be pointing the opposite direction. So they're anti-parallel. They're going the opposite direction. So be careful because the order does matter. So, so let me give you an example. Find the vector whose initial point is P2 comma 3 and terminal point is Q6 comma 4. Okay, and then we're gonna graph it, and I'm gonna show you how to graph. So the first thing that you want to do is that we need to figure out where exactly the terminal point and the initial point is. You can see that the terminal point is going to be this Q and the initial point is going to be this P. So the way that we can write this vector, we can write V if you want, or you can just write PQ and then an arrow. Okay, so remember that what we need to do is we need to subtract the terminal and the initial point. So it's going to be the terminal, which is 6. We're going to subtract 2, so that's 6 minus 2. And then we're going to take our y's, 4, and subtract the other one, which is going to be 4 minus 3. So my vector is going to be 4 comma 1. This is going to be my vector. So basically what I just graphed, so if I wanted to graph it, we can just do it this way. So we can graph both points. So I'm going to graph P. So 1, 2, and then 3, 1, 2, 3. Okay, so this is point P. And then Q is going to be 6. 1, 2, 3, 4, 5, 6. And then 4. So this is going to be this vector. So basically, the arrow is pointing in this direction. So if you can see, you can kind of, let me see. You can see that in the x direction, from here to here, it is 4 units away, which is basically this guy. And then in the y direction, you can kind of see that it's 1 unit away. That's that guy. Okay, so this is basically the vector PQ. That's the vector PQ. Notice if I was to retract it, then the arrow would be pointing the opposite way. So the head would be where the tail is, and vice versa. Okay, so making vectors are pretty self-explanatory. They're not that difficult to kind of do. But there's something else that we want to kind of talk about. So basically, a vector is a standard position vector if its initial point is at the origin. Okay, so standard position vectors. So usually it's much easier for us to not have this vector up in space. So notice we have this vector up in space here. It's sometimes easier to just have it at the origin, right? So starting our vector so that its tail is right there. Okay, so how can I write this vector that I just found in standard position? Well, it's going to be really easy. All we got to do is look at the vector that we created, which is 4, comma 1. We're going to go 4 units from the origin, 4 units over 1, 2, 3, 4, and then 1 unit up. Kind of imagine that woodchuck taking the slope. And then we're just going to draw an arrow. And actually, this vector is equivalent to the other vector. This is still vector PQ. All I just did, imagine that I'm just taking this vector, grabbing it, and I'm placing it at the origin. So these two vectors are equivalent. They're exactly the same vectors. And sometimes it's easier to work with vectors that are at the origin. Okay, they're starting right there. Okay, so that's basically how you create a vector and how you can graph them. A couple of things that we can do, because component form is not the only way that we can write it. So we have component form. So component form kind of looks like this, 3, comma 2. Okay, so you have, it's probably the easiest one to kind of work with, but you have another one which is called IJ form. An IJ form is basically the way that we can write this vector is just 3I plus 2j. And here, I is equal to 3, comma 0, and j is equal to 0, comma 1. And later, oops, that's wrong. I is equal to 1, comma 0, j is equal to 0, comma 1. And later on, we'll talk about these two, and they're actually called unit vectors. So there's just shorthand notation. So basically, what you're doing is that you're taking the G and you're adding an I next to it, and then you're taking the 2 and you're adding a J or multiplying a J to it. And later on, I'll kind of explain what these two are, but just for right now, just take it as a given. So like if I wanted to say rewrite negative 4, comma 6 with I and j, then basically what you would write, you would take the negative 4, attach an I, and then take the 6 and attach a j. That's basically what it is. Okay, so very, very easy. If you wanted to do it the opposite way, you have to be very careful because I see this often. If I say rewrite negative 5I plus 2j as components, the way that you want to do it is you want to write the brackets, the pointy brackets, put the negative 5 in there and the 2 there. Okay, one thing to not do, so don't do, is do this. Negative 5I 2j. This is not correct. Same thing with the other one. You don't want to write negative 4I plus 6j. That's not right. Where you're trying to combine two different things. So don't do that. That's not right. That's not correct. Okay. So one of the things that I wanna be able to do also is talk about magnitude. Okay. So when we talk about magnitude, we're basically talking the length or size of the vector. So if you kind of imagine drawing a vector, okay, and it has two components, let's say you had the components as x and y, so let's say you had x comma y, so that means in this direction is x units, in this direction is y units. You can pretty much see that by the Pythagorean theorem that this guy is just going to be x squared plus y squared. So the way that we're going to write magnitude is kind of like absolute value of v, of the vector. And this is going to be equal to the square root of the first component plus the second component. So this is the formula for magnitude, or the size of the vector, how long this vector is going to be. Okay, so let's give a couple of examples. Okay, find the magnitude. Okay, so let's say we start off with this vector u is equal to 2 comma negative 3. Let's say you also want to find the magnitude of b, so let's say w is equal to 3/5 I plus 4/5 j. Okay. All right. So how would you find the magnitude of this? So to find the magnitude, all you got to do is take each of the individual components, take the square root, and then square the sum. Okay. So this is going to be the square root of 4 plus 9. Okay, so this is going to give me the square root of 13. Okay, so this is the exact magnitude. Okay, if you want to find the approximate, you could just put it in the calculator. And now let's find the magnitude of this vector. So in this vector is in ij form. We can still do it. So square root, take the first component, 3/5, square that, and then take the other one, 4/5, and square this one. Okay, so this one's going to be 9 over 25 plus 16 over 25. That gives me the square root of 25 over 25. That's just going to give me 1. So the size of this vector is 1. And actually, this vector is a vector that is called a unit vector. Okay, and that's what we're going to start off in the next one. So basically, a unit vector is going to be a vector that has size 1. So we'll talk about that in the next video.